Hello and welcome. In this lesson, we will cover the switch case structure in Arduino programming. The switch case structure is used for decision making, and it's one of the most useful tools for controlling flow in a program based on specific conditions. A variable's value is continuously tested against a list of predefined cases. When the variable's value matches one of these predefined cases, the corresponding commands are executed. Now, let's analyze the switch case structure in detail. After writing the switch statement, we enclose the variable name in parentheses. This variable is the one we will be checking. Inside the curly brackets, we define case blocks, each specifying a constant value to compare against. For example, we can write case 1. If the variable's value equals 1, the corresponding commands are executed. We then use the break command to exit the switch block, ensuring that the program does not continue checking other cases. Since the condition is already met, there is no need to evaluate further cases. We continue with case 2. If the value does not match case 1, the program checks if it equals 2. If so, the corresponding commands are executed, followed by another break statement. This pattern continues for all necessary case blocks. Finally, if the variable does not match any case, we use the default block to specify what should happen in that scenario. The default block works in the same way as the else clause in an if-else statement. If no case matches, the commands inside the default block will be executed. The break statement should also be used here. There is also a point we need to pay attention to here. If the variable being compared is numeric, the case values should be written as plain numbers without single or double quotes. If the variable is of string type, we need to write the values inside the case blocks in double quotes. Similarly, if the variable is of char type, we write the values inside the case blocks in single quotes. As you can see, the switch case structure looks similar to if-else statement. We see the code for an application where pressing the button connected to pin 2 of the Arduino turns on the internal LED connected to pin 13. The code is written using both the if-else and the switch case structure. In the program, the value of the button pin variable, representing pin 2, is read as either 0 or 1 and is assigned to the button state variable. If button state is high, meaning the button is pressed, the let pin variable, representing pin 13, is set to high and the LED turns on. If the button is not pressed, button state takes the low value, and since LED pin will also be set to low, the LED remains off. Both the if-else and switch structures perform the same function in this example, and there is no difference between them. The switch case control structure is similar to the if-else structure, but there are some important differences between them. For example, in the example displayed on the screen, if the temperature sensor data is between 0 and 10 degrees or between 10 and 20 degrees, different LEDs turn on. This type of comparison can be easily done using an if-else structure, as we can check whether a variable is greater or smaller than a specific value. However, the switch case structure works a bit differently. In switch case structure, a variable's value can only be compared to fixed values. For instance, if the temperature sensor data is equal to 0, we can execute a certain action, or if it is equal to 10, we can perform a different action. However, these operations can only be applied to specific fixed values and cannot define a range. So, while everything that can be done with switch case can also be implemented using if-else, the reverse is not always possible. This is because switch case does not allow logical comparisons. It strictly evaluates whether a variable matches predefined constant values. Now, let's briefly review the rules we need to follow when using the switch case structure. First, when writing a switch case statement, we do not place any character after the variable inside the parentheses of the switch statement. The subsequent code is written within curly brackets. After the case keyword and its value, we use a colon instead of a semicolon. Each case block must always end with a break statement. The fourth important point is that using the default case is not mandatory. If none of the defined case values match the variable, you can use default to specify an action. However, if you do not need this, just like in an if-else structure, the default statement is also optional in a switch case structure. Lastly, char variable values must be enclosed in single quotes, string values in double quotes, and numerical values should be written as they are in the case blocks. So, in which situations is it more advantageous to use switch case? If a variable needs to be compared against many fixed values, the switch case structure provides a more organized way to write code. Compared to the if-else-if structure, it offers a more readable and structured code flow. Some common areas where switch case is advantageous include menu-based applications, such as when designing programs with multiple options, like user interface menus or command line selections. It is also widely used in state machines, particularly in embedded systems, microcontrollers, and game development, where different states require specific actions. Additionally, keypad and button handling is another area where switch case shines, as each key or button input corresponds to a unique case. Overall, switch case is preferred over if-else structures when dealing with multiple constant conditions because it significantly improves code readability, execution efficiency, and maintainability.